Hi, so I'm Nick. I'm from Blecon, and today I'm going to be talking about how to combine combine white label hardware with open source software. So hopefully everybody in the audience is kind of aware that you can go much faster when you use open source software. But if you're building a hardware-based product, the fact that it's hardware-based now adds a whole new can of worms, and things can get much slower and much more annoying. And so I'm going to talk about kind of our experiences kind of using kind of pre-made white labeled hardware to really speed up the development process, and then mixing that with great open source software like Yocto to ship a hardware product much faster. So to begin, I want to give you an intro to what we do at Blecon. This is not a talk about Blecon, but it's good to have a bit of context. So what Blecon does is we build infrastructure to connect small Bluetooth devices up to the cloud. So imagine kind of a little temperature sensor, so that would communicate through Bluetooth through a device up to a cloud. And so what we started with were phone apps. So apps on phones, apps on laptops. And so we were very much a software company. But our customers started wanting to use these sensors in areas where there might not always be a person around. So we had a customer who was tracking sheep, and so they needed to put a gateway inside a barn, and so there wasn't going to be a person in the barn. Or we had a customer who was monitoring temperature in a freezer, and so again, you wouldn't have a person with a phone inside the freezer kind of acting as a gateway for these Bluetooth devices. So based on that, we were like, oh, well, we need to have a dedicated piece of hardware, a dedicated hardware hotspot in order to serve these customers. And so the problem is, as a startup, so we're a really tiny startup with 7 people. Thanks, so half of my company's here with these 2 guys in the front here. Hardware is not good news if you're a startup, I think, because hardware products and startups are a really, really difficult match. When you're starting to ship a hardware product, you really need some new skills that that we didn't have. So you need, a mechanical engineer to do the enclosures. You need maybe some people who do kind of production design and make test plans. And so although we're pretty much generalists at the company, I think there are definitely skills that we didn't have. And also, it's a big time sink. So I know a lot of this firsthand when I used to, in my old job, and I'd have to go to China to go visit the factories to kind of make sure the production line was getting set up correctly. And so that's kind of a luxury we didn't have, kind of, it's a tiny company. Also, kind of just all the process, all the steps that you need to kind of get a hardware product shipped is massive. There's a lot of time needed for certification, for other stuff, and all of this ends up costing money. And so it really kind of building a hardware product is almost like the antithesis of like doing the lean startup, right? So they say like don't spend a lot of money up front, don't spend a lot of development time, minimize waste. But oftentimes when you're building hardware, you're committing a ton of money up front to kind of buy a bunch of parts or kind of get your factory set up, get production set up, and so the upfront costs and the scaling curves are really, really challenging when you're doing hardware. And so I guess, and definitely there are kind of blog posts and kind of articles about how you can kind of sidestep some of these. And maybe this talk is a little bit about that, right? So this is, how you do hardware without having to do hardware. So for those of you who aren't super familiar with building hardware, the thing to really keep in mind and to know about shipping hardware is that really kind of your prototype is really just the first step, the tip of the iceberg. To give you a taste of what's involved. So you might have your prototype, you might actually have, your electronics all fully working. And in a way, I think, the fact that prototyping and building electronics is so much easier now surprises people how hard the rest of the process is. Today you can basically get your design, get your PCB made, shipped from China, fully assembled, in a matter of weeks, and all that's taken care of. But what that you don't see is, to get from that point to kind of a shipping product, you have to still do kind of the mechanical design, you have to do certification, you have to get kind of FCC, RF certified, kind of you have to go to test labs for that. If you have kind of custom mechanical enclosures, you have to get mechanical tooling built, so that adds money because you have to get these molds made for your injection molding. There's a whole series of verification tests to make sure that your device kind of doesn't fail when it's too humid or too hot. So there's kind of time spent doing that. You have to build kind of factory tooling so that when the person in the assembly line, they can basically pull down a lever so that and test your product, and then come up with test plans so that these guys who are very much not your experts on your product can kind of reliably test your product, and then all sorts of other kind of related things like inventory that. So it's a pretty involved process, and so for hardware for startup, this is really actually something you don't really want to do. But the good thing is, I think this is a challenge that everybody building hardware faces. So there's actually a lot of solutions out there for you to kind of, depending on your needs, to choose between. The whole spectrum of options that kind of range from, on the one side, kind of completely fully custom electronics. And this is really good if you need to build something super specific, super custom for your particular application. And so you'd have to do everything from scratch. In the middle here, I think probably kind of this is what most people are doing. If you're doing kind of small runs, you have modular hardware. So this saves you from having to do kind of all of the electronics design, a lot of the certification. But you are still responsible for things like, the mechanical design, your enclosures, and also the whole process around the manufacturing. And at the very far end of the spectrum, you have white label hardware. So these are devices that some factory has already designed, has already built, probably is kind of selling for some other customer. And so the great thing about these things is basically it's very little work, because all of the manufacturing processes, the enclosures, the plastics, all of that's done. And so that's great. But what you give up there is you give up a lot of customization. So you're really kind of locked into oftentimes the manufacturer software and choices they've made. So obviously, depending on the specifics of your application, then different points of the spectrum make sense. Today, I'm going to be talking about this kind of what I'm calling kind of, it's not quite fully white label, so kind of pulling back a little bit and kind of what I'm going to call kind of hardware-only white label. So we're going to be using just the hardware, which is actually surprisingly robust oftentimes, and replacing all of that hardware with kind of our own custom software. So to start, I'm going to talk about why it makes a lot of sense to go kind of more on the white label part of the spectrum, especially if you're in startup mode and still testing hypotheses and trying to determine whether you're even building the right thing. And so the reason is by using kind of more white label things, you're really leveraging the ecosystem strengths, right? So you have these massive economies of scale, right? These factories are pumping out, hundreds of thousands of these devices. And, if you only need like 100, 500, 1,000, all of that kind of extra work has been amortized across that massive volume. So cost-wise, is going to be much more advantageous. Most of the times, these devices have already been made, and so they've already gone through certification. They've gone through verification testing, and the big thing here is that it really saves on time. Oftentimes, to get kind of FCC certified, that's a couple months. To do kind of your full suite of validation testing and make sure stuff doesn't fall over when it's too hot, that's kind of another couple months. So a lot of the times, kind of white label devices, they've already got that taken care of, so nothing to worry about. And then the last thing is this is kind of there are fewer surprises, right? These things have been made kind of en masse. There's going to be the factory knows how to make these things, so there's not kind of as much risk there for things to go wrong. And then the other thing I want to mention was that as much as kind of I said that when you're going white label, you really are fixed into kind of choices that the designer already made. There's actually still quite a bit of room for customization, as I kind of surprisingly learned. A lot of times these days, these devices have a lot of late binding kind of features. So like the plastics. So on this device, this is our device. We could choose to change out kind of the colors, the silks, the printing on the plastics. So that gray piece over there on the right. We could choose a different color. And then a lot of the back stuff was all laser engraved. So if you needed to customize the labeling or instructions or whatever, there's a lot of flexibility there. So actually, there's still a bit of room for customization when you're doing white label stuff. But if all of this is so great, I guess I wouldn't be here talking about, why kind of scrap all of the software on these devices and kind of take this more hardware only approach, right? And so the reason why we chose to go down this path initially was we kind of did we weighed kind of all the options we could do, and we noticed that, well, first of all, our software requirements were a bit kind of different than kind of what the original devices were designed for. So like I mentioned, we do some Bluetooth things, and so we needed some low-level access to the Bluetooth hardware. These were embedded devices that were going to be potentially placed in locations that were challenging for people to access, so we needed kind of much higher kind of robustness, resiliency guarantees on these devices. So we were probably going to have to change the software quite a bit anyway, from the stock devices. Another aspect, and I think something that a lot of these kind of white label devices tend to struggle the most with, is actually user experience. They don't have great kind of UIs and getting started experiences. And we also wanted to make our kind of differentiate ourselves by having a really amazing plug and play kind of user experience with kind of with a cloud-based configuration and whatever. So again, we were probably not going to be able to reuse the stuff that they had. And not that we really wanted to reuse the stuff they had with in regards to their user interface. So kind of on that side, we basically were like, oh, well, the existing software wasn't providing us a huge amount of value. And then in addition to that, we were really worried about maintainability, right? So a lot of these devices have really poorly documented software. It tends to be kind of passed along between multiple people, and it's really nobody really owns the code. And so we were really worried that if we just kind of use the vendor software over time, the code would rot, and then we wouldn't be able to maintain it very well in our company. And then the last thing I think is probably a big concern for many people, kind of particularly with these kind of devices kind of coming out of Asia, is kind of security, right? They're all running pretty kind of outdated kernels. Nobody's really maintaining them. Nobody's kind of applying security updates, and that's something we definitely knew that we didn't want to kind of put out there for the world. And so we were like, oh, well, we needed to be responsible for maintaining the software on this thing. And with a pure white label approach, where we're just taking the software and maybe kind of changing the software loadout just a little bit, we didn't feel like we could kind of give that sort of those types of security guarantees. And so kind of these were the sort of the gaps that we saw in the white label approach, which kind of led us to going down this more this hardware only approach. And I guess if you're also seeing sort of if you have some of the same concerns, you're seeing some of the same problems, then maybe this is kind of an approach that might work for you as well then. Let me just do a quick time check. I'm going to just briefly, in a few minutes, get into kind of the mechanics and the logistics of and the process of building kind of out a kind of a product using this approach. But just to kind of give you a bit of a timeline and kind of cost involved, just to kind of ground things. What ended up happening was from end to end, so from us deciding on kind of which vendor we were going to use, I was able to kind of get the software developed and get the device made in about 6 months. So it's not really quite, build an MVP over the weekend yet. I mean, it'd be great if it was, but I think 6 months is actually pretty good for getting kind of a full shipping hardware product. So I think if you look on the internet, most people would say budget about a year and a half to 2 years to kind of if you wanted to do everything from scratch. And so kind of the things to call out. Well, so most of the time actually was spent me kind of actually building our firmware. Rather than the factory. So if you kind of add that up, it's maybe about 6, 7, 8, let's say 2 months. 2 months of time to kind of get once you kind of get the firmware up to the factory for them to kind of set everything up. So the turnaround is really, really quick. And just as a point of comparison, early on, we actually kind of wanted to see if we want to change some hardware around, make things a little bit more custom, what that would entail. So if you want to change the hardware, then they add the factory quoted 12 weeks to add kind of to do the verification. And then if you wanted to change out radios and that sort of thing, that's another 8 weeks for certification. So that gives you kind of a sense of the sort of time cost you're paying if you're kind of doing something a bit more custom. And also, when you're doing some more custom stuff, there's a lot more setup fees and that sort of thing. And so you're also paying a lot more there. So kind of sticking with the more kind of existing hardware white label thing can be quite advantageous. Right. So for the rest of the presentation, I'm going to share my experiences kind of developing and shipping this hardware product. I've kind of grouped kind of my experiences up into 3 sections. One is about setting up, kind of getting prepared. Second is about kind of actually doing development. And then the third one is preparing for manufacturing and kind of working with the factory. And I tried to kind of curate them. There's plenty to talk about. I can kind of spend kind of hours and hours talking about. So I really tried to find kind of like the 3 top things that I felt like were worth investing in, or that I learned from, or things that I thought was, I wish I knew about going into this to cover. Okay. So the first section is really about kind of gathering information, making sure you're making kind of a good choice so that you're setting yourself up for success. So although I'm going to present this more like you should have done this, you should do this, you should do this, that was definitely not how it worked for us. It was very much organic. And then only kind of in retrospect and hindsight, when I'm looking back, I'm like, this would have been good to know. And, there's a bit of survivorship bias here too, right? So if I hadn't done those things, I probably wouldn't be up here talking about this. I'd probably be like, don't go with white label hardware. It's a terrible idea. Yes. So maybe the first thing, kind of the biggest boost I had was, and where I got lucky, was I ended up choosing a platform that was fairly well supported, both in the Linux kernel, in Yocto, and that kind of made things so much easier. Obviously, not saying you can't go with kind of a really obscure platform, but you're going to spend a lot more time kind of developing for it. Maybe the kernel maintainers would be really happy because you're adding new support for a new platform. But if you're trying to go fast, it really makes sense to go with something that has support. And ways to tell whether something has good support. Well, I've kind of used whether I could get kind of dev boards conveniently as one kind of metric to see whether this is kind of a platform that was kind of that was worth using. And then also I went through kind of Yocto and looked at the layers to see if if there was something kind of pre-built for it, because didn't really want to fight. It was already kind of quite challenging to build the software to not to have to kind of develop for the platform as well. And so the other thing that you should probably do that really helped me was, and this is kind of something, again, I mentioned this is something more organic. I kind of ran into a problem and then would ask for the schematics, but kind of looking back, it'd be great to have kind of these schematics and have some data available. I don't know how comfortable manufacturers and vendors would be sharing kind of the full schematics, but actually from my experience, they've actually been really, really helpful in kind of at least giving me the bits that I needed. And the things I really felt like you should ask for are, the location of test points, where the debug ports are, where the UARTs are, so that you're able to kind of see what's going on. And the other thing that was useful, but was what they called an SDK. And so the thing is, I think this is how I knew what we were doing was not really on the beaten path for this particular vendor, was that the SDK they gave me ended up being this tarball of their Git repo. And then when I did like a Git status on it, there was a whole bunch of unstaged changes. And then if I kind of like look kind of more closely, I can definitely see that, and I think this is kind of probably the rule rather than the exception, is that a lot of this the software that the firmware for these white label devices are kind of pieces of code that have been handed on and passed along to kind of different people. So when I was digging through the SDK that they gave me, I found like random Chinese audio files, because I think the platform was originally used for a smart speaker, like a kind of Alexa thing, and then eventually they kind of remove the microphones and turn into a Wi-Fi gateway, and then turn it into some other thing. So basically, be prepared. It's not going to be pretty, but it's actually really, really incredibly useful to have that in mind, because it is at least something that builds, and you can use it as a reference for later development. Okay. And the last thing I think I wish I knew when I went into this whole endeavor was I wish I was much more knowledgeable about the device tree. So, going into it, I kind of knew about it, but, it was definitely kind of a learning on the job sort of thing. And in retrospect, I think I would say like 80% of kind of getting something running on one of these platforms is going to be kind of hacking the device tree. The thing about modern platforms is that they're all using kind of the same kind of SoC. So there's very, very actually kind of little core differences between hardware. A lot of the differences really is just which pins they're using to kind of on the SoC for the UART, and so then it's really just kind of modifying that or what peripherals are being bolted onto the thing. So a lot of time is spent kind of messing around with the device tree, and what I found is, as I learned more about the device tree and understood how everything works, I was like, there's something kind of a thing that I didn't understand before, and I ended up going back and patching it. So I think it would probably be more efficient if getting more familiar with the device tree ahead of time would be really beneficial. Okay, so the second section I have is around kind of streamlining your development after you've kind of got all this information in hand. So I'll share some learnings about how I think you can make the development process a little less frustrating. Obviously, the biggest challenge when you're working with this white label hardware is you're working on somebody else's hardware that you didn't design, and oftentimes it's kind of in a state where it's not meant for development, right? It's already kind of a production piece of hardware, and so it's not kind of a lot of signals and things that would normally be accessible if you were developing is not super accessible. And then obviously when you're working with other people's hardware, I'm sure when you run into problems, when you run into quirks, it's really hard to tell whether it's your fault, or say, the hardware designer's fault, or maybe it's the maintainer of the software's fault, or if it's just the hardware acting up, right? And so that's also kind of a big challenge. So kind of the biggest thing I found super helpful here was, as painful as it is, I really, really, really recommend kind of getting access to all the debug ports, all the test points, solder wires, get somebody who knows how to solder to kind of connect that up for you, because that's kind of paid back massive amounts of dividends for, I've kind of had to kind of, look at these signals kind of more often than I like to admit. Something I wish I knew before I soldered this was there's this really amazing tool called this PCB Byte, and it's got these little probes that you can just drop down on test points, and it's just incredible. Don't have to solder; you get access to kind of these little tiny signals, and so wish I knew about that. And kind of my weird hardware kind of hacking tip. When soldering kind of to these pin headers, I used to solder directly to the metal bits of the pin headers, and that was always really brittle. The wires would always fall off. Sort of kind of in a fit of rage, I kind of soldered to this breakout board for a NeoPixel, and then threaded the wire through one of the through holes as a strain relief, and it worked out really well. So you can probably do that well with a perf board as well. But this hasn't broken yet, so. That was probably a good idea. The other thing that was kind of a big level up was getting to the point where I could experiment with more confidence without worrying about breaking the system. So one of the things that we did was being able to test an emulation, and I'll talk a little bit more about that the next slide. The other thing was setting up the system to boot from removable media. That was a huge game changer because, if something broke, I'd just pop out the SD card and I could replace it, or, I wouldn't be super concerned about having to go dig out random tools to unbrick myself. And then the way I think I did this, and this is great, and I think this is really a testament to kind of the power of kind of and the flexibility of our open source tools now, is in U-boot it's super easy. You just using the U-boot standard boot, setting the boot dev ordering meant that you could prefer to boot off the SD card rather than the embedded eMMC. And then the other trick, I think this is something Yocto does by default already, is basically instead of passing a specific device ID to the Linux command line, being able to extract out the partition ID for the partition on the SD card or on the embedded memory, and then booting based on that. And so at runtime, it figures out which partition to boot from, which is really great because that meant I could spit out one image and not have to worry about whether it was going on an eMMC or if it was going on an SD card. And as the system booted, it would find the right partition. And then it's also good, and this is where kind of the documentation and kind of the test points and that sort of thing really are really helpful. It's also, in the worst case scenario, you still have you'll want to know how to get into kind of recovery modes on the hardware platform. On ours, it was you had to short two random test points, and then it put itself into kind of recovery mode, and then you could go and erase the memory and start from scratch. I mentioned kind of testing and emulation. Actually, the kind of a huge, massive investment, and I think that really paid off, which might not be obvious, is building for multiple platforms really, really early on. We're only really developing for one platform, one piece of hardware, but it really paid off to set up our Yocto system to build for multiple platforms, because each one of them has kind of its distinct advantages. So like I mentioned, it was really nice having dev boards available because these dev boards had all the signals exposed. Even though the hardware configuration was slightly different, it was often much easier to test our firmware on the dev board rather than on the final hardware. And Yocto makes this super, super easy because it has this whole machine setting. You just kind of change the environment variable, and then it spits out a different image based on the hardware. Oftentimes, testing on the QEMU emulator platform was also really useful. I think the main uses for this were it's really easy to kind of back out things that modify the system. So testing OTA was really, really helpful using the emulator because I messed something up. Okay, well delete the file and start over. Didn't have to kind of even pop out the SD card to kind of reflash stuff. And then the other really, really beneficial thing that was actually testing on the host PC itself. So a lot of our, thanks to my colleagues who've kind of had the foresight to write a lot of this code in a very cross-platform way, you could also actually test a lot of our code, not on the system itself, but on, say, on your development system. And then that was kind of also really, really good because then you could just, you had a really tight dev loop on the host system. And then using kind of the DevTool system in Yocto, it was very easy to then point Yocto to that source tree and then build a new version of the whole system using kind of the changed code. So setting up kind of the multiple platform builds for Yocto ended up being a really good investment. And the thing that we did here was we really we set up, we had all the other layers. We didn't touch any of those, but we split up our code and our contribution, our stuff into kind of two separate layers, one being Blecon, which is basically hardware independent things, and kind of a Blecon BSP, which was kind of all of our hardware dependent things. And this had the advantage of keeping us honest. So stuff that was hardware dependent kind of didn't kind of accidentally get into the Blecon part. So that meant that I think when we do kind of build real custom hardware, if we ever go kind of mega volume or move to a different platform, supporting that will be a lot easier than having to kind of unpack everything. Okay, so at this point, you're probably done with, at some point you're going to be finished with development and it's going to be time to kind of actually get something made. And let me get to that. So this last section is going to be talking about challenges around manufacturing. And as I mentioned, we're doing things a little bit off-piste for for these manufacturers. So so the challenge here really is making sure what we're doing is compatible with their testing flow. So one of the things about the factory is that they often need some pretty low-level access to the system. So they often need to have kind of shell access to be able to run certain commands. This might be for radio testing or for some secondary programming, or even just kind of manual inspection. Oftentimes they will like randomly sample things off the production line, and they would like to be able to poke into it and make sure that it's actually running the right software just for kind of quality control. And this, as you can see, is sort of in tension to kind of building a really secured system, right? You don't want to kind of give, giving the factory root access also means potentially giving root access to people in the outside world. And so one solution might be to kind of, we'll have the factory, flash their testing firmware on there, and then do their tests, and then flash the production firmware on. And that's sometimes viable, but actually a lot of factories don't like doing this because it adds a lot of time. And oftentimes the process it's less about the time, but also it kind of inverts their flow almost. So they're set up to flash, test, and ship. And if you kind of say, oh, flash, test, and then go back to the flash station and then do this other thing, I think they kind of start getting a little bit antsy, and they're like, oh, well, this feels a little bit too complicated for us. So these kind of extra rounds of programming might not necessarily be prohibitive, but definitely kind of not recommended from my experience. So kind of our solution here, which I've not seen people really do, is actually piggybacking off our OTA system. So with our OTA system, we have A/B partitions. So in OTA, you would basically download the update to one of the new partitions and flip over when it's finished downloading. But actually, you can adapt the system for manufacturing testing as well. So what we do is then we have the kind of the factory testing image, and this is actually built using the manufacturer provided SDK. So it's an environment that they are very, very familiar with. It's running kind of some super old version of the Linux kernel, some random libraries that their tools are compiled against. So from their perspective, this is kind of exactly the same as a system that they're very much used to. Stuff that they have, tools that they have that are kind of binary only will run on it. And so this is really clever, really convenient for them. And so then they can run all their factory tests in kind of the B partition. And then once they're finished, there's a script that they run, which will basically write a piece of data into the U-boot environment. And then that flips. This is the same mechanism that OTA works with, which is it flips the active partition, and then at that point the device now boots into kind of the prod image. And then I think the thing that we added also in the prod image is on the first time it boots, it runs a little bit of self-test to make sure that it was flashed properly, and just make sure everything's working okay. After that, it kind of writes a file into et cetera, and then from then on the system starts up kind of normally. The other thing I learned when trying to kind of get this thing made is that manufacturing images are often not the same as development images. So when you use Yocto, often what pops out is an image that you can copy onto an SD card or flash onto eMMC directly, and the system boots and everything's great. As it turns out, at least for kind of these rock chip parts that we were using, the manufacturing image that they needed to be packed a very, very specific way. And the reason is because the tooling that the factory uses comes from Rockchip, and it needed special kind of a very, very special layout that has like an integrated bootloader. So what happens is the thing that flashes the device loads the bootloader on, which actually enables USB, and then it can connect through that to go and write all the data out to flash. And so you need to kind of run these really, really esoteric tools. A lot of them are pretty, they require kind of really weird configurations. Like it needed like Ubuntu 18 point something, and it had to be on a x86 32-bit system, and it's pretty nasty. And it's kind of a big kind of a set of steps that you need to follow to kind of output this image. So kind of the lesson here was that build automation was absolutely critical. So I think it's really well worth spending time kind of automating both the Yocto build, but also kind of automating the packaging step because it was so much nicer to not have to worry about that. And so you can see kind of this is roughly the flow. So we have our Yocto build kind of built in GitHub Actions, and then that pushes up to the OTA service, but also kind of dumps release artifacts, and then the manufacturing build will pull the release artifacts and package everything up. And so that it's very reliable, and kind of once this was working, kind of my stress levels went down drastically. And then the last thing is, of course, there's going to be surprises. As kind of careful as you are, little things will crop up. So differences in your testing environment happened. We discovered that the cellular modules, these were the bane of my existence. They're actually super, super complicated. They store a ton of state. And so as part of the testing process, the factory was writing some state into the cellular modules, and then my system wasn't kind of reacting correctly to that. Factories missteps, and they can something else that was really annoying was they changed parts on me kind of midway through. So and I think this tends to be worse for white label hardware because typically they don't have to worry about that because the guy writing the software is sitting right next to the guy working on hardware, so they don't really have to document a lot of these changes. The solution here is really just to kind of be really diligent about getting golden samples, so kind of getting a final version, making sure that's working to kind of and always check that every single manufacturing run. And so once you've received your shipment, there's a whole kind of slew of other topics that I won't have time to get to today. And so kind of to wrap up, I want to show you want to recap that. So this hardware-only kind of white label approach is really an option that combines the expertise of these hardware vendors and manufacturers with kind of probably our expertise in software. And so it can result in some really, really kind of fast time to market, lower costs, and while preserving kind of software quality and security. And definitely there's some unique challenges that come as a result of taking on this approach, but things like Yocto and U-Boot kind of make this a lot easier to do. So yeah, I wanted to kind of share kind of all the other Blecon folks that are at the conference this week, and that's it. Thank you so much.